Huge GPU clusters in the form of data centers have perhaps been the biggest investments ever known to man. We're about to watch a clip predicting perhaps another cycle just as large in the AI space might be on its way, and that AMD could be a huge benefactor of it. Check this out.
What's happening with AI now is that it's pretty obvious for everyone, not just the AMD bulls, the longtime AMD bulls, that AI is moving out from the data center. Of course, there will be a lot of AI in data centers, but essentially every single machine on the planet will need an inference chip to use AI and do something useful with it. Essentially, my view is that AMD is positioned to take the whole inference market. And that is because when you perform inference on a device, you basically have less space and you have a smaller battery. Much less power than you would do in a data center. So there's thermodynamic requirements that force you to be much more efficient in order to use AI at the edge, essentially. Now, this market is going to explode over the next 5 to 7 years, I believe. Potentially could take 8 to really come to fruition, but it's going to be, physical AI is basically going to be one of the big end markets, at least as big as NVIDIA's data center market is today. Now, AMD is valued just a few $100 billion, just to give you the exact number, $279 billion. And so if it does turn out that they have a roadmap, which I believe is so well suited for physical AI, and actually a bunch of other markets, but just take one, which is physical AI at the edge. If it does turn out that this does become one of the primary markets for AI, at least as big as the data center market today, and AMD has this unique competitive advantage, then this becomes a multi-trillion-dollar company. As many of you know, I'm long AMD since 2014, since $4.2 per share. So at $420 per share, I'll be up 100x. But I actually believe that this is going to get much bigger, because at $420 per share, AMD is still nowhere near the end market cap it could attain if it does actually become the primary player in physical AI, which again is just AI at the edge. Again, why do I believe this is happening? And why do I believe the market is now starting to price this in aggressively? If you look at AMD's AI PCs, so the chips that they recently launched over the past year to bring AI PCs to the market, they really are, and I think, people have had such a tough time wrapping their head around this over the past year, but they really just are a CPU and an FPGA combined. The FPGA is the chip that I've talked about so many times here on the channel, which basically reconfigures itself on the go, changes shape in order to run different neural networks more efficiently. So it basically takes on the shape of the neural network at the circuit level, and that enables you to optimize AI workloads, specifically inference, in a way that no other chip can. It's this roadmap is not science fiction. It's happening already, because that is how AMD is now essentially growing its client segment so fast. AI PCs powered by AMD are selling very quickly because customers find them useful. And, firstly, the OEMs are buying the chips. And then eventually, I think, over the next few years, we'll see end consumers just using AI for everything when it comes to PCs, essentially.
Okay, firstly, I wanted to make sure that clip was as accessible to everyone as possible. So I asked Rock to define FPGAs for idiots like me. So an FPGA is a flexible chip that can be reprogrammed to handle AI tasks like real-time video processing or autonomous driving, making it perfect for edge AI. Edge AI is AI not in the data centers, it's out in the cars, in robots.
Or the robots,
Or the robots, stuff like that. AMD, according to Grok, leads in edge AI with offering high performance, low power, which is important, and adaptability for smart devices such as drones or 5G networks. So I think to break down that clip, maybe first we want to break down two of the key assumptions. One of the key assumptions is that edge AI is going to be huge and moving away from data centers, or it's going to be as big as the data centers. So do you firstly agree with that? How big do you think edge AI is going to be? And do you think it is a comparable market to data centers?
100%. It is going to be huge. There are obviously different ways that robots and computers are going to provide value to people, but what we saw, I think, in the Web 2.0 Cambrian explosion of technology over the last decade is probably a good rough analogy for what we're looking forward to. That we got a lot more powerful devices in our hands, but then there's this beautiful and complicated interrelationship between the data, like the experience that you have as an end consumer on that phone, and where computing actually happened to provide you with that experience. And a lot of it happens right there on your device, but then a lot of it still happens in clouds somewhere. And so the situation that you would actually be interacting with something that was cloud-based versus local, that changes based on the context of whatever you're doing. And so, if you're watching YouTube videos, well, those are stored in a cloud somewhere that's far away. But then if you're doing other things on your phone, all that data lives locally. And in order for the ultimate hopes and dreams and possibilities of what this technology is going to offer to be brought into the real world, you need that existence of both cloud computing, strong networking, and then local computing. And then you need to be able to shift around, what is being computed in the cloud, what is being computed locally, what is being transferred over networks, over what speeds. And yes, and I agree that, like if you look at the amount of chips that people have, like the total computing power of just every iPhone on the planet, that the magnitude of that amount of computing power is insanely huge. And then, especially if you, now add in all the Samsung handsets and all the LG handsets and, everything that's made by Huawei and all the Chinese phone manufacturers, like it is a gargantuan amount of total compute that exists in cell phones. And I think that the magnitude of edge compute now, that's not just going to be on cell phones, but like he said, every robot, which there's going to be a whole lot more robots, all sorts of machines that we already use today that exist that just haven't been imbued with this intelligence yet. Those are going to also have computing power on them. So like the magnitude of applications that we're going to apply this type of dynamic, where we're putting, essentially it's going to be, the cell phone for every major device in the world. That's just going to be an incredible amount of total computing power that we're going to build. We're going to generate it. We're going to install it. We're going to integrate it in applications near, far, and wide. And it is going to be massive. And at the same time, we're also going to be continuing to build out massive data centers. And so, yeah, like I think thinking about them as roughly equivalent in orders of magnitude is correct.
Okay, so that's the first assumption. The edge market is going to be gigantic and as big as data centers, or at least in that order of magnitude. The second one then is AMD the leader, or potentially going to be the leader in the edge AI market? So how well positioned do you see AMD to be there? Because if so, that's an enormous opportunity for another NVIDIA-like moment.
Yeah, so I'm definitely not like an expert in AMD and their business model. I think that they're in a very interesting position, that they have a lot of opportunity ahead of them. And especially when you compare their market cap to some of the other big players who have been successful in this area, I think their potential as an investment opportunity is very high. But I think there are also challenges that Antonio's not really addressing here that I don't know how to handicap them. Maybe they're not as big of challenges as I think they are. But, what he has described here, these FPGAs, those are field programmable gate arrays. Those are computing devices that you can change the flow of logic, in a programmable way, but actually like the chips, the logic transistors, all of the actual computation is configurable. And so you can define how information flows from, one part of the chip to another part of the chip. And so, yes, you can define in a much more flexible way how the hardware handles the software computation that you want to do. And that's very interesting. It's very exciting. It does theoretically offer AMD the ability to provide more efficient inference and more configurable inference than other architectures. But then you have to ask the question, okay, how hard is it to develop software for that? And what does the software development ecosystem look like that enables that. And this is one of the areas where AMD has really struggled and lagged behind, and that NVIDIA has been so successful in. And, NVIDIA, we've already talked before about how they have their CUDA ecosystem, which is the software ecosystem that allows lots of developers to write these brand new AI applications and get a lot of performance out of NVIDIA GPUs for these brand new applications. And it's one of the biggest, richest, most valuable software ecosystems in existence on the planet today. Has every indication of continuing to grow. And so, the question will be, can AMD provide developers with the tooling necessary to really attract them into this AMD ecosystem to develop their edge inference software for? And I think that that's going to be a little bit more of a challenge than Antonio has described. Now, I have seen significant progress from AMD over the last specifically 12 months on being much more software focused and really realizing that they're not going to be able to develop this ecosystem with closed source proprietary stuff that, they do in-house, so that they're going to have to rely on creating a community, and specifically an open source community, to solve the magnitude of this software challenge for them. If they can continue to gain traction in that way, there is a possibility that AMD could create basically, a Linux style equivalent to CUDA over the coming years. And if that were to happen, I think they do have actually a very strong possibility to capture even more of this inference market. Now, that said, so now we've talked about NVIDIA, we've talked about AMD. There's also, people like Tesla that they are developing their own edge AI inference compute with AI4, AI5, AI6. They have this whole roadmap. They're planning to double down with Samsung from AI6, and then we'll see where it goes from there. But they are taking their destiny into their own hands from a computing standpoint. And then they're also facing all the challenges that come with developing software for those inference computers. And they're trying to develop a platform that is, a unified architecture that converges from the data center chips to those inference chips. And this is another area where NVIDIA, we'll circle back to NVIDIA, is doing as well, that they want to have the same chips actually live on Optimus robots, in Tesla cars, that they're also doing a significant portion of their training in the data center with. And so there are some, differences in the ways that those chips are packaged and put together and coordinated. But at the end of the day, it is actually the same devices in the cars as in the data centers, and that allows you to have a very tight feedback between data that you're pulling in from your edge that you want to modify your behavior around, and then being able to train on that, change that behavior. If you need to change it in the cloud, you can. You've got the same architecture. So that's interesting. NVIDIA, with their, Jetson AGX Thor release here recently, they are putting Blackwell GPUs in these chips. And so they have kind of a similar architecture that they're moving towards, that Elon is doing with the AI 6 and Dojo 3, and all unified around their CUDA software system. And the bet that Jensen is making with that is that, yes, maybe you could theoretically get better performance with an FPGA over Blackwell from an efficiency standpoint, that you do more operations with less electricity. But if you create the biggest platform and you push scale as far as possible, that you can actually outcompete on the same, tokens per watt type of metric, what people who are creating these specific, ASICs or FPGAs can do. And so far, he's been very successful with that strategy in the data center, that we've seen lots and lots of different companies who are trying to build chips that are better than NVIDIA chips. And, there are lots of different ways you can think, okay, NVIDIA chips are inefficient like this, they're inefficient like that. And so if we build our chip over here in a way that eliminates those things, then we can be better than NVIDIA. And we've seen, those companies kind of repeatedly fail to actually deliver on performance that is superior to NVIDIA GPUs. The Dojo 2 example being one that the audience should be very familiar with, that Elon tried to do this with Dojo, and the H100, H200, and Blackwell GPUs that NVIDIA is making, seems like they're better at training the types of workloads that Elon has most of the time. And so while they do have Dojo 1 operational, they're going to build Dojo 2. They are going to have some Dojo 2 operational. For the majority of workloads, NVIDIA data center GPUs actually still work better. They're more efficient. They're more cost efficient. They're more power efficient. They're capable of doing more things. And so that's the type of bet that AMD is making, is, hey, we can create a more efficient computing platform to do these things than NVIDIA. And because it can be more efficient, well, it obviously must take more market share. And it's also possible that they'll end up in the same type of position as Dojo or Cerebras or, a number of other training compute startups that have come into play over the last few years that are trying to disrupt NVIDIA in the data center. AMD could face the same types of challenges in trying to disrupt NVIDIA at the edge as well. And because, this edge market is not something that Jensen is sleeping on. We talked in a previous episode about how Jensen loves to build platform businesses. He loves to build the widest platform ecosystem possible to enable and empower, the most use cases. And he's been thinking about robotics in this way as well. And so you don't see AMD trying to provide the total ecosystem to train robots that Jensen and NVIDIA are doing right now. And so that ecosystem that Jensen is creating for robotics is also something that pulls people, developers, technologists into this NVIDIA ecosystem to build their software to run on the edge in the first place. And if they built it there, are they going to leave that then to go over to AMD to run inference because they can do it a little bit more efficiently? Maybe, maybe not. I really don't know. So I'm just much less confident about AMD's ability to take the whole inference market, as Antonio said, than he is. I think they have a very strong shot at being a player, a significant player, capturing a significant portion of the market share. But I think for me, it's much more likely that they are a minority market shareholder in that market than a majority, much less, the whole thing. That's my read on where we're at.